All right, hey guys. So first I just want to say good job on Evaluate. I'm really proud of how hard you guys work on that, and I just want to thank you guys for taking that seriously and doing the absolute best that you can do on those tests. So as the board says, the first thing that you should be doing after you finish Evaluate is to get your Evaluate packet out so that you can look back at your past 3 Evaluate scores and write those down so you can kind of reflect on how you've been doing and see your progression since we took our first one in September. So if you haven't done that, please pause this video and do that first. If you're done with that, please make sure you physically have this packet in front of you because these are your notes, so you need to be following along with me as well. So last week we were talking all about simplifying expressions and being able to first identify what an expression is and then be able to identify like terms and how we can combine those and how we can simplify our expressions. And today we're just going to delve a little bit deeper into expressions and talk about linear expressions and how we can add and subtract those. So first, what is a linear expression? So a linear expression is an algebraic expression in which the exponent of the variable is 1. And so remember, we talked about exponents before, and so if you notice all of these examples for the linear expressions, you'll notice that all of the variables, there's just 1. There's no exponent to it. So if you see -4, x, 3x, 1/6 x, there is no exponent. So we can say the exponent of that variable is 1, because if you guys remember when we talked about variables, what a variable means is if we have our base of x, the variable, the exponent, say we have our exponent of 1, which is what this definition is telling us, this right here, this exponent would be telling us to multiply our base of x by how many times the exponent tells us to, which is actually 1. So if you were to do that, you would just get x. So that's just a little bit of clarification of when it's saying that the exponent of the variable is 1, you can always assume if it says -4x, that is the same as saying -4x to the power of 1. It's just there's really no point of writing that power of 1 because x to the power of 1 is just x. So then our nonlinear expressions, and the reason that that's called a linear expression, let me back up a little bit, is because if you look at linear, it kind of sounds like line and even has that word line in it. So when we start graphing these out, which we'll do in the future, if you were to graph out -4x, if on a coordinate plane, it would be a line, it would be a straight line. However, when you get into these nonlinear expressions like x squared or -x cubed plus x, these are not going to be straight lines. They might have curves in them, and so they're not going to be linear. So that's why it is called a nonlinear expression. So to go ahead and add these linear expressions, there are 2 methods I'm going to show you guys. So there's a vertical and there is a horizontal method. So in example 1, it's just asking us to find the sum. And on A, I'm going to use the vertical method. And then B, I'm going to show you guys how to do the horizontal method. And so these are just 2 different ways that you guys can have in your toolbox of, whatever you feel most comfortable with on how to solve these. So the very first thing I'm going to do is what we talked about last week is turning all of the subtraction into addition. And the reason that I do that is just for you guys to better see which number has that negative assigned to it. So for instance, if you can look at x minus 2 and know that that subtraction sign also means that the 2 is negative, then you can leave it as is. However, if you haven't been able to identify that, if you look at that and you're not really making that connection yet, that's totally fine. But then I would recommend turning everything into addition using that keep, flip, change, so that you can see where the negative sign is attached. So if we did keep, flip, change in x minus 2, we would keep the x the same, flip or change, whichever acronym you want to use, the subtraction to addition, and then we would change the +2 to a -2. Okay, and so you guys might see, or this should look pretty familiar to you guys because the past couple units when we were talking about integers, this is exactly what we did. So x plus -2 is the exact same as saying x minus 2, just so you guys know. And then I'm going to add on the rest, so plus 3x plus 8. So now that we have full addition, I'm going to go ahead and use the vertical method. So I'm just going to line these up vertically. So I have x plus -2 plus 3x plus 8. And then you can go ahead and just add these as you would if, say, you were adding two whole numbers together. So -2 plus 8 we know is 6, because remember, if you're ever adding a negative to a positive, it's the same as subtracting. So 8 minus 2 is 6. I'm going to bring down that addition sign, and then 3x plus x is 4x. And so one thing that I did, and this is our in simplest form, as you guys can see, because remember, talking about those like terms, 4x and 6 we cannot combine because they don't have the same variable. So this is in simplest form. This is our sum. One thing I did want to go ahead and cover with you guys is something I was noticing last week when we were completing our mazes, simplifying the expressions, is some of us were having trouble adding the x's together, especially if it was just one single x. And so one thing that I wanted to make sure you guys understand is when you see this 3x, we've simplified that. So if you were to expand 3x, oops, and that's a 2, if you were to expand 3x, that would be the same as writing x times x times x. So all we're doing is we're combining all those x's together and just putting the coefficient in front, that 3. So that is just saying that there are 3 x's, and on the first row there is just 1. So if we were to count up all these x's, we have 1, 2, 3, 4. So we have 4x, which you could, write as x times x times x times x. But that, eventually gets very tedious to do, and it's just not as clean and simple and easy to look at and to count out. So that's why we put that coefficient in and we say 4x. All right, so that is our vertical method. So just lining up vertically our two addition problems, and then adding like we would normal if we had two whole numbers, just doing the same thing. The vertical method is a little different. All this is doing is regrouping horizontally, and then simplifying. So again, the first thing I'm going to do is make sure that we turn all of our subtraction into addition. So we still have -4y plus 3 plus 11y, and then I'm going to do the keep flip change. So we are left with plus -5. And again, if you're fine with keeping it -5 and knowing that that 5 is negative, then by all means you can keep doing that. But I just want to make sure that we all know that the negative sign is attached to that 5 as well. So now I'm going to kind of just do the same thing we did last week, is regroup these by what our like terms are. So our like terms, remember, like terms, they have to have the same variable. So there is 4y and 11y. So we can say -4y plus 11y, and then I can add the other two like terms, plus 3 plus -5. Okay, and then I can just continue to simplify. So -4 plus 11 is going to be 7y. And then 3 plus -5 is -2. And you can rewrite that out back in subtraction form, would be 7y minus 2. So that would be our simplest form. So as you guys can see, and I really want to make sure that you guys can see how 7y plus negative 2 is the exact same as saying 7y minus 2. So all you're doing there is that keep flip change that we have talked about in the past. All right, so our last example before you guys try some on your own. I hope that this is, you're kind of getting the hang of it by now and you're feeling a little bit more confident. So it says find 2 negative 7.5z plus 3 plus 5z minus 2. So the first thing I want to do is I want to distribute this 2 into the what's inside the parentheses. So you guys can use distributive property. And so with distributive property, just like I drew those little arrows, you have to distribute whatever is on the inside. You have to multiply it by everything that's on the outside. So you could do this by saying 2 times negative 7.5z and 2 times 3. Okay? The other way that you could do this, and I wanted to show you guys this just in case that method doesn't make a lot of sense to you. All this is saying when there are 2 outside that parentheses, it's just saying that there is 2 of everything that's in that parentheses. So the other way you could do this is you could literally do what we just did vertically, do vertical addition. So we have negative 7.5z plus 3, and we have another one because it's saying we have 2 of them. So we have negative 7.5z again plus 3. And if you add these up, you would get 6. 3 plus 3 is 6. And then you would get negative 15z. So all that 2 is saying is that there is 2 of everything that is on the inside of that parentheses. So that's why when you do the distributive property, you have to remember to multiply the 2 or whatever numbers on the outside by everything that's on the inside. Because remember when we, even last year in 6th grade, when we talked about the PEMDAS, when we talked about parentheses first, parentheses includes everything that's inside those parentheses. That's why we do parentheses in math. It's because we want to include not just one solo thing, but multiple things together. And so that's why when you have the negative 7.5z plus 3, when you have that 2 on the outside, it's saying that there is 2 of everything that's in here. So you can either use the distributive property if you feel confident with that, or you can line them up vertically and add them. It's going to be the same thing because all you're doing when you're doing the vertical is repeat addition, which is multiplication. So whatever method that you feel the most comfortable with. So now that we have that, we have negative 15z plus 6 plus 5z, and I'm going to turn that minus 2 or negative 2 into plus negative 2, just so that we know that the negative sign is attached to that 2. So then if you want to stack them up vertically, you can, or if you want to use the horizontal method, whatever you feel most comfortable with. I'm personally just going to use the horizontal method. So I have negative 15z. I'm going to regroup here. Negative 15z plus 5z. Those are like terms because they both have z. And then I'm going to add the 6 and the negative 2. So now I can simplify. Negative 15z plus 5z is going to be negative 10z. And then positive 6 plus negative 2 is going to be 4. So this is my sum. We are in simplest terms here because we don't have any other like terms, so we can't combine them any further. So we are left with 10z plus 4.